Bessel function. This huge formula here is called the Bessel function of order V. So let's prove. To start the proof, we first of all state the Bessel differential equation is giving us s squared y prime prime plus xy prime plus s squared minus v square y equals 0. This is the general differential equation, the Bessel differential equation. So to start, we use the Frobenius method to prove. Now to start, we say s squared equal to 0 implies that s equal to 0 is an analytic point. Then x, divide through by x squared. We have y prime prime plus x over s squared y prime y equal to 0, so which is y prime prime plus 1 over x y prime plus s squared minus v squared over s squared y equal to 0. This is equation 2. Call this first one 1. In this case, p of x is equal to 1 over s, this value, and q of s equal to the second one. So take note, this analytic point is said to be a singular point. That means x is said to be a singular point here. Now I want to see if the singular point is regular or irregular. Now we take the limit as x tends to 0, x p of x is equal to limit s tends to 0, x p of x 1 over s, which is 1. S cancel s, and which is equal to 1. Then the second one, q of x is s squared q of x. Take note, is equal to lim s tends to 0, s squared into s squared minus v squared over s squared equal to 0. Sorry. And this one is equal to lim x tends to 0, s squared minus v squared is equal to minus v squared. So both of them are defined, they are not undefined. Hence x equal to 0 is a regular singular point. Okay, so in this case we get the initial equation, but before then we need to get our p naught is equal to p of 0 and is equal to xp of 0 and is equal to 1, and s squared q naught, it's not s squared, and q naught equal to s squared key of 0, and which is equal to minus v squared. I hope you know how I got this. Remember, this is p of x equal to 1 over x. So p of s will be s times 1 over s equal to 1. Then the other one, q of s equal to this. So s squared q of s is equal to s squared minus v squared, because you cancel this. Now in this case, okay, at s equal to 0, then s squared q of s is 0 minus v squared, which is this. Now let's get the initial equation. The initial equation is r into r minus 1 plus p naught r plus q naught equal to 0. We have p naught is 1, which is r, no? Okay, then plus q naught is minus v squared equal to 0. R squared minus r plus r so r squared is equal to v squared, so r equal to plus or minus v. Alright, now we have two solutions for the Bessel differential equation. The first one is plus v, the second one is minus v. So let's start. Let y equals summation a n x n plus r, y prime equal to summation n plus r a n s n plus r minus 1. Y prime prime equals summation n plus r minus 1 a n s n plus r minus 2. Substitute y prime and y prime prime into equation 1. That means our original differential equation, which is this. Now s squared y prime prime is this, so you put it there. Then plus x y prime is n plus r a n s n plus r minus 1 plus s squared minus v squared y summation a n s n plus r equal to 0. This guy is equal to summation n plus r minus 1 a n. Take note, here we have s squared. So if s squared move into here, you have 2 and minus 2 out, remain n plus r. The same thing here, if s move into here, we have 1 minus 1 out, remain n plus r. The same thing, you will still open this bracket, s squared times this v squared times this. Alright, let's do it. So we have x n plus r plus summation n plus r a n s n plus r plus summation a n s n plus r plus 2 minus summation v square a n s n plus r equal to 0. These two places are, so if this one open, you have that minus v square, which is this. Okay, from here now, what we do now is this: compare the coefficients of xn to look for xn here, xn here, xn here, xn here. So for you to get Sn, s is power n, that means r must be 0. Okay? If r is 1, you cannot get xn any longer. Instead, it will be x is power n plus 1. So, but if r is 0, then you have s is power of n. In this case, r will be 0 or 2, and is a coefficient. So we have n, r is 0 into n minus 1 a n. No need to write Sn because you are comparing the coefficients, plus here the same thing, r is 0, so we have n plus 0, n a n. Here, if r is 0, even if r is 0, you have n plus 2, so this one won't work. Then here, minus v square a n, r is 0, is equal to 0. So we have I'm sorry, there's an error here. We have to compare the coefficients of xr, not sn. It's still the same thing, sorry, it's still the same pattern anyway, of xr. That means n will be 0. We just turn it around. So at n equal to 0, here we have xr. Now put n to be 0 here. R, here will be r minus 1 a naught plus here r x, sorry, a naught, here no, then here minus v square a naught equal to 0. So r this plus r minus v square a naught. In this case, for this to happen, a naught not equal to 0 and r into r minus 1 plus r minus v square equal to 0. So you see that this is the initial equation we had previously, where r is equal to plus or minus v, remember. Now let's make another comparison. Compare the coefficients of xr plus 1. Now let's go back. Xr plus 1, n will be 1. Not so? N will be 1, n will be 1. Yeah. If n is 1, it won't work. even if n is 0, it will be r plus 2, so this one will not work. Now when comparing, we have n is 1, so 1 plus r minus 1 a1 for here, 1 plus r minus, then plus the next one, 1 plus r a1 minus v square a1 equal to 0. So this is also called r plus 1, r plus 1. So here is r into r plus 1 plus r plus 1 minus v square a1. In this case, okay, let's continue. We have r plus 1 into, if you factor r plus 1, factor it, r plus 1 plus 1 common, pick 1. If r plus 1 cancel, you have r, cancel, you have 1 minus v square a1 equal to 0. In this case, either a1 equal to 0 or r plus 1 minus v square equal to 0. So in this case, a1 is equal to 0. This implies that a1 equal to a3, all the odd values will be 0. So we now deal with the even values. Call this equation star, because we may still use it. From star, apply shift of indices or shift of index to the third term. While we're applying shift of index to the third term, check the first term, n plus r, the second term, n plus r, the fourth term, n plus r, but this one, n plus r plus 2. So we need to make everything uniform, x plus r, so that we can easily factor it out. So to make here n plus r, then we need to subtract 2. And if we subtract 2 here, then we must subtract it for any value of that term we see n. Here now there's an, so we subtract 2 from here, because we are subtracting it from here. So we can't just do it only here, so we still need to do it here also. So we have an minus 2 Sn plus r. Alright, so we can now factor out our summation n plus r minus 1 an plus n plus r an plus an minus 2 v square an into s n plus r equal to 0. Now this one is the same as n plus r n plus r minus 1 an plus n plus r an plus an minus 2 v square an equals 0. So this one is the same as factor these three. We have n plus r minus 1 plus n plus r minus v square an plus an minus 2 equal to 0. We can easily move this to this other side. N plus r. Okay, sorry. Let's factor these two. So this and this is common. Pick one. Pick one. Then if you divide, it will remain this. Plus, if you divide, it will remain 1. And this there. Minus v square. an. N plus r into n plus r minus 1 plus 1 is out. Remain n plus r minus v square an equals minus an minus 2. Alright, let me write it again. N plus r square minus v square an equals minus an minus 2. So an is equal to minus an minus 2 n plus r square minus v square. This is called the recurrence relation. Alright, now let's start with at r equal to v. Then an will be minus an minus 2 all over n plus v square minus v square an minus 2, open the bracket, or difference of 2 square, n plus v, or let's open the bracket if that's what you wish to make it easier. We have n square plus 2nv plus v square. If you open it here, then minus v square into n square plus 2nv. V square minus v square is out and is equal to minus an minus 2 all over n. We can factor out, pick 1. N divide n square is n plus n divide n remain 2v. This one is for n equals 2, 4, 6, just like that. Because we are dealing with even things, not odd. So we have an equals minus an minus 2 n plus 2v. So at n equals 2, we have a2 equals minus a naught over 2 plus 2v, which is minus a naught all over 2. So let's call this one 2 factorial, 2 factor 2 out. So it will remain 1 plus v. Then at n equals 3, at n equals 4, we have a4 equals minus a2. Just substitute it, 4 minus 2. You understand? Here at n equals 2, so 2 minus 2, all over n is 4 into 4 plus 2v, and is equal to, what is a2? This is the whole of a2, so we replace it, minus a naught 2 factorial 2 1 plus v, this is a2. Then we still have things under, so we just write it, and this is equal, minus minus is out, a naught all over, can we do something here, factor 4, okay, 2 factorial times 2 times 4 times, okay, we can factor 2 out, into 1 plus v, then factor 2 out will be 2 plus v. Take note what I did here. I factored 2 out, which is this. If you factor 2 out, it will remain 2 here and v, which is equal to a naught all over okay, so I'm sorry, let's go back to see this place. Yeah, if we factor it out, it will be 2 times 2, which is 4. So this one is not 2 factorial 2, it will be 2 raised power of 2. Then this one will be 2 raised power of 4 times 2 here is 2 factorial. Next one, n equal to 6, a6 is equal to minus a4 all over 6 into 6 plus 2v. This one is minus a4, 6 times 2 is common, 2 into 3 plus v, and a4 is this, which is a naught all over 6 times 2, 3 plus v. Then these are things here, to raise power of 4, 2 factorial, 1 plus v, 2 plus v. Take note, this one now will be 2, 2, 4. So 2 to the power of, which is 2 raised to the power of 6. Then this 6 is 3 factorial. Now we have a6 equals minus a naught all over 2 raised to the power of 6, 3 factorial, 1 plus v, 2 plus v, 3 plus v. Just like that, a raised power of 2n, because it's even 10, 2n minus 1 raised to the power of m a naught is so, because we have minus plus minus, let's watch. Here is a2 is minus plus minus, you understand? So that's why we have this thing, and all of them ends in a naught. So here is 2 raised power of 6. So take note, here and here always be the same, so we still write it 2n. Then take note, if you divide this one by 2, you have this. Check it. If you divide, okay, this one is this. So if you divide this by 2, you have this. You see, it's the same thing. So 2m divided by 2 is m factorial. Then 1 plus v, 2 plus v, dot dot dot. Yeah. If you divide this by 2, you have this, or this, so which is m plus z. So in this case, your general term, that is your y1, is equal to summation minus 1 n a naught all over 2m m factorial 1 plus v, 2 plus v, dot dot dot, m plus v into x 2m plus v. Remember, just remember something. Y equal to summation a n s n plus r, where your arrow is v. So this is what we expounded here. The general term of a is this, and which is this. N is equal to 2n, so which is this. Arrow equal to v. So we now have, okay, yes. So a naught is an arbitrary constant. So a naught is equal to, let a naught equal to 1 all over 2 v gamma v plus 1. So you try to revise your gamma function very well, because we use the principle here. In this case, we have y1 of x equals, anywhere you see a naught, you put 1 over 2v gamma v plus 1 to 2m m factorial 1 plus v, 2 plus v, m plus v, 2m plus v. Bring this one down, which is 2m m factorial 2v, yes, gamma v plus 1 plus v. It's still the same thing, 2 plus v, other v plus 1 also, m plus v, and is equal to, oh my god, summation minus 1n x 2m plus v all over 2m plus v. That means 2 common. So you pick one and you add indices, just indices. M factorial okay, let's use 1 plus v, anyone. 1 plus v gamma 1 plus v, then 2 plus v m plus v. So this one, just recall something. M gamma m equals m plus equals gamma m plus 1. M plus 1 gamma m plus 1 equals gamma m plus 2. So just like that, m plus v gamma m plus v. So you see that you always add plus 1 here, extra plus 1, like this one now is m plus 1, then plus 1, plus 2. So this one now will be gamma m plus v plus 1, not so. So that's what we do here, equals minus 1m is 2m plus v all over 2m plus v m factorial. All these ones now will be gamma m plus v plus 1, so which is summation minus 1n over m factorial gamma m plus v plus 1. Then these two, they are the same. We can just group it in brackets, s over 2 into 2m plus v. And this one, so this is the Bessel function at m equals 0 to infinity. So we have j v of x equals m equals 0 to infinity minus 1m all over m factorial gamma m plus v plus 1 2m plus v. Also at arrow equal to minus v, we are through with at arrow equal to v. Now let's move on to arrow equal to minus v. Don't be afraid, you won't solve much, just to replace it here, and that's all. J minus v of x is equal to summation m equal to 0 to infinity minus 1m m factorial m minus v plus 1 s over 2m minus v. Thanks for watching. Subscribe for more.